so we've done lots of word problems where we have figured out how much is going to be in an account after a certain time, or how many people are going to be in that city after a certain time, for example. These problems are asking how long is it going to take for a certain thing to happen. So instead of how much is there, it wants to know how long. And how long means you're looking for time. If you're looking for time, time is always in the power. So the reason that these are just a tad bit different is because you're going to have to use what we know about logs to solve it. Okay, so I'll show you what I mean. So the first question says we have this town of 5,000 people. It's growing at 3% per year. And we want to know how long it's going to take for the population to double. Okay, this right here is still our P. That's our starting value. Our 3% is our rate. Remember, move our decimal over 2 places to the right. If I want to know how long it's going to take for it to double, that right there is telling me I want to increase the starting value by 2. I want to multiply that by 2. So that's telling you that A is 2 times 5,000, so A is going to be 10,000. Now notice in the problem I don't see compounding. The word compounding is not there. The word compounded continuously is not there. So I'm still going back to that very first equation that we've used before. Okay? So it's the A equals P times 1 plus R to the T. That's the equation we're looking at. And our A is 10,000, so we'll have 10,000 equals 5,000, 1 plus 0.03 raised to the T, because T is what we don't know. So, not very different from what we've done, except now I can't just plug it in the calculator because I'm looking for T. So now I'm going to try to get T by itself. Okay? And I want to do it similarly to the way that we solved some of the equations. This is an exponential equation, so I'm probably going to rewrite it in log form to try to find it. What I want to do first is I want to divide by 5,000 on both sides. If I divide by 5,000, I'm going to get 2 equals 1. And then I'm going to go ahead and add that 1 in this 0.03. So I get 2 equals 1.03 to the T. Alright, now, in order to solve that, this is where we rewrite it in logs. If you have exponential, you rewrite it in logs. If you have logs, you rewrite it in exponential. That's your process. So we're going to say log base something. Now, this is written backwards from the way it normally is. If you want to rewrite it as 0.03 to the T equals 2, that's the same thing. That means our base is the 1.03. Our 2 is what we're taking it of, and that equals T. So that right there is what we would put in the calculator in order to find out how long that it would take this population to double. So you either go to the calculator or go to Desmos to plug that in. And that would be 1.03 of 2. So in the calculator it looks like that. And so it's going to take about 23 years. So number 18, 100 is the amount you start with. The 175 is the amount that we're trying to get to. 8% is your R. And move your decimal over 2 places. And we're looking for T because we're looking for how long. So we're going to say that 175 equals 100 times 1 plus 0.08 to the T. Again, no compounding in there, so I don't have to use those other equations. Alright, so from there to solve it, I'm going to start by dividing by 100. So you get 1.75 equals, and I'll go ahead and add that, 1.08 to the T. To get that T to come down to find the power, that's when we do the log. We just rewrite it in logs. So log of whatever the base is, of whatever's on the other side of the equals equals the power. And then that's what we put in our calculator or into decimals. Log 1.08, 1.75, and you get approximately 7 years. Alright, let's look at number 19. So in number 19 it says that we have a 15-gram sample of radioactive iodine. It's decaying in such a way that the mass remains after T days is given by this function. So they've given you the function, which means I don't have to worry about like coming up with the equation. I'm going to use the equation that they gave me. How many days is there only going to be 5 grams remaining? So they're giving me an equation, and this is what I want. I want 5 grams to be like the answer. I want that to be how much is there after a certain amount of time. That 5 is going to go right here. That's m of t. It doesn't mean m times t. You're just taking the 5 and plug it in the place for the whole thing. So you're going to have 5 equals 15e to the negative 0.087 t. So that one's kind of nice because they went ahead and gave us the equation, but now we've got to figure out how to solve it. Okay? Now, I need to get the e and the power by itself. So what do you think I'm going to do first with that 15? Divide by 15. When I divide by 15, 5 divided by 15, it's 0.3333. I'm just going to write it as 1/3. If you want to write it as a decimal, that's fine. Okay? Now that I have e to a power or a number to a power equals something, this is where I can rewrite it in log form. You guys can write it in ln form or log form. Which would you prefer? Log. You just want to do it the same way. That's fine, no problem. That would be log. E will be the base. The 1/3 is going to be beside the e, and that's going to equal the negative 0.087 t, because that's the whole power. The reason the natural log would be important is because it just makes it a little bit easier since the base is already e, but you don't have to do it that way. You totally can just do the log and not worry about it. So we're going to have log base e of 1/3 I get that. So negative 1.099. That's not the answer though, because that equals negative power times t. So what do I do on both sides now? Divide it, exactly. So I'm going to divide it by negative 0.087, and that's going to give me 12.63. In this problem, t is in days, and so that means in 12 days that iodine is going to decay to 5. Any questions? Alrighty, number 20. What equation are we going to use in this one? So I see that compounding right there, and that right there clues me in. So I have to use that equation because it says compounded quarterly. Go ahead and set that up. We'll see if you can solve it, and then we'll talk about it here in a second. So what is the amount that we're wanting after a certain amount of time? 20,000, because we want it to double. So I know this is going to be 20,000. What's our starting value? 10,000. 1 plus, okay, R is the 8.5, so that's going to be 0.085. Quarterly, tells me the n, so I know that's going to be a 4. And I'm going to raise that to the 4 times t. Now, after I solve that, my first step is to get rid of that 10,000 because I want it to be a number to a power. So how do I get rid of that 10,000? Divide by it. So I'm going to have 2 equals whatever that is. I'm going to go ahead and put that in the calculator. 1 plus 0.085 divided by 4. It's kind of a long decimal, but it's not real long, so I'm just going to write the whole thing. Now that I have a number equals something to a power, this is where we do the log form. So we're going to say log base whatever's in parentheses of what? 2, and then equals the power. So in our calculator or Desmos, whichever you prefer, you're going to put, if I go to the right thing, log, not there, start again. Okay, log 1.02125 of 2. Hang on just a second, we'll talk about it. After that, what do? Divide by 4. Alrighty. So in this problem, we want our investment to go from 5,000 to 8,000. That's telling me that 8,000 is the amount that I'm looking for, and 5,000 is the amount I'm starting with. My rate is the 9.5, so that's 0.095. Excuse me. We're doing this monthly, so that's divided by 12. And that means we're going to be raised to the 12t. First step would be to divide the 8,000 by the 5,000. You get 8/5 or 1.6. And I would go ahead and work out that part right there. 1 plus 0.095 divided by 12. And you get a very strange decimal. When you're trying to decide like how far to go with it, I'm going 4 places on this problem just because there's a bunch of zeros right there. As long as I can see your work, it's going to be okay however you have it. Just to match it up with multiple choice, the more places you go, the better off it will be. From there, we're going to rewrite it in log form. And that thing in parentheses, that's our base. And then we're doing it of their answer equals 12t. I want to show you in your calculator how you can use that whole decimal. So look here for just a second. When you go to alpha window and do your log, if you want that number to be that number, you can go up to it, press enter and grab it, and it'll put that whole thing there so that it doesn't mess up the rounding. Even though on paper it'll mess up our rounding, in here it won't. So I just wanted you to see that you could grab it like that. And then from there you're going to divide by 12. So we would get about 5 years. How long will it take for $1,000 to triple? That right there tells me that I'm trying to get to 3,000, since 1,000 is what we're starting with. It tells me it's continuously compounded. This means we're using PERT. So it's 1,000 and then e to the r, which is 0.065 t, because I'm still looking for the time. What do we do first? Divide by 1,000, and so you would get 3 equals e to the 0.065 t. Go ahead and do our log, because you guys like doing the logs rather than the LNs. So log base e of 3 equals 0.065 t. So then we're going to go to our calculator. We're going to put base E, and we're going to put 3, and then we're going to divide that by 0.065.